Now we know where lead compounds come from, so what are some considerations when we want to design them? We will discuss some considerations and particularly some of the approaches that we will take. Let's talk about isolation and purification. This includes solvent-solvent extraction, chromatography, crystallization, and distillation. For this approach, some drug molecules dissolve in certain solvents better than others. For example, some prefer to be in water, while some prefer to be in oil. So how exactly will we extract the drug molecule from a certain solvent? There is distillation, where once the drug has dissolved in a certain solvent, how do we get out the solvent and keep just the solid drug part? One, without destroying the drug itself, or certain solvents evaporate faster than others. So these are some of the considerations we need to do in order to isolate or purify the drug compounds we want to use. Next, we want to determine the structure, not just the physiological structure of the target, but we also want to know the structure of the drug. And these can be used different techniques such as elemental analyses, molecular weight, different spectroscopy and spectrometry, or crystallography. We won't go into all the details here because there's a lot of science behind it, but again, if you're interested, you can look at the technical resource section. Next, natural products have medicinal properties or potential to do a lot of different things, but we want to see what exactly are some of the properties, whether how we will use it as a medicine, what are chemical properties, potential side effects, toxicity, how well it treats the diseases, how heavy it weighs, how will we want to administer it, is it through injection or is it through pill? For example, here, let's take a structure of morphine. How can we use this structure to modify to something that is perhaps not as strong, not as addicting, or if you have any side effects, how can we reduce it by changing the physical or chemical structure of this compound? Let's talk about some of the physical chemical properties we need to take into consideration. One of the first set of rules we want to consider is the rule of 3. For example, the molecular weights, we don't want it to be more than 300 Daltons. Daltons being the molecular weight units that we use for small molecules. We don't want to have more than 3 hydrogen bond donors and no more than 3 hydrogen bond acceptors. Hydrogen bond donors or acceptors is essentially how much interaction it has with molecules or compounds that can do hydrogen bonding. We won't go into the details of what hydrogen bonding is, but it's essentially interaction with things that generally has oxygen or hydrogen molecules that creates a pull and push effect. An example of a compound or molecule that has hydrogen bonding is water, because it's made up of oxygen and hydrogen. We want to consider how many bonds within the molecules can rotate. We don't want it to rotate too much of more than 3. For C log P, we don't want it to be more than 3, which is essentially a criteria to say how much you like water. And lastly, the polar surface area of the drug, we don't want it to be more than 60 angstrom. And another rule is Lipinski's rule of 5. We don't want it to have more than 5 hydrogen donor, no more than 10 hydrogen acceptors. The molecular weight should be less than 500 Daltons. And again, how much it likes water, we should not have it exceed more than 5. And generally, these are chemical or modified lead compounds. Now we have to follow these set of rules. But if your ligand is a natural source that comes from protein or things such as RNA, we have to consider phenotypic screening. Phenotypic screening is a type of screening used in biological research and drug discovery to see these proteins or peptides, small molecules that we want to screen and study and understand it more, because we can actually modify these compounds in a way that we want to be used. For example, insulin is a type of peptide, a small molecule protein, similar to a small protein molecule. If we were to modify this, we need to do a phenotypic screening so we can modify it in a manner we desire. Perhaps we want to increase its absorption or have resistance to breakdown. Any kind of advantage that we want to induce or any modification, we should undergo phenotypic screening. Okay, so in this section, we talked about the different stages of drug discovery, from target or phenotypic screening, hit ID, lead optimization, and lastly, preclinical development. All this to find possible candidates that we possibly can use for clinical trial. We talked about sources for drug discovery, which can be synthetic, natural, or virtual. And lastly, we discussed some of the considerations when we design a lead compound. And again, there are additional information for the technical aspect in the resource section. I'll see you in section 3.